Hello guys, so this is an algebra problem from the 2000 AIME 1, and this is problem number 7. So suppose that x, y, and z are three positive numbers that satisfy x, y, z equals 1, x plus 1 over z is equal to 5, y plus 1 over x is equal to 29, and then z plus 1 over y is m over n, and we want to find m plus n where m over n is in lowest terms. Okay, so first of all, let's list what we know, right? We know that x, y, z is equal to 1. We know that x plus 1 over z is equal to 5. We know y plus 1 over x is equal to 29. And then we know z plus 1 over y. M over n is a little bit wacky, so we'll just call it k. Okay. So now what we want to do is we want to somehow find z plus 1 over y. So the best way to do this is we know x, y, z. We know x, y, z is equal to 1. So we have to think, how can we use our remaining three equations to somehow form an xyz so that we can use that fact into solving this question? So an immediate obvious answer is just multiply these three numbers, right? If we multiply it, we'll surely get that xyz, and then we'll also get a 1 over xyz, which we know is also 1. And then maybe we can use some of the symmetry in our additions to get something where we can find k. So let's try this. This is just wishful thinking. And in fact, this is actually a symmetric problem. X, Y, Z are all symmetric. So it's actually a good idea to try to multiply around things and then try to see if you can get something. So x plus 1 over z, y plus 1 over x, and then z plus 1 over y. Let's multiply these two together. So we'll first deal with the first two terms. Let's just do that multiplication. That's xy plus 1 plus y over z plus 1 over xz. And then times z plus 1 over y. Continuing, we can distribute the z over. That gives us x, y, z plus z plus y plus 1 over x. And then 1 over y over gives us x plus 1 over y plus 1 over z plus 1 over x, y, z. Okay, great. So if you don't immediately see it, then let me just regroup the terms for you. So this is just xyz plus 1 over xyz. Both we know which is the value of 1 since we're given xyz equals 1. And then now what's neat here is that we have a bunch of sums. All that look like are x plus 1 over z and y plus 1 over x and z plus 1 over y. We can group this to clearly see that this is indeed true. We do have our x plus 1 over z hidden over here, y plus 1 over x over here, and then z plus 1 over y over here. So all terms are accounted for. Now what is this equal to? Well, we multiplied these three terms, so it's 5 times 29 times k, which is 145k. And at this point, we know a bunch of these values, so let's just plug these in. xyz plus 1 over xyz, as we said, is 2. X plus 1 over z is 5 given by the problem. Y plus 1 over x similarly is 29. And then z plus 1 over y, that's our k. This is plus k is equal to 145k, and now this is just a simple linear equation. 2 plus 5 plus 29 is equal to 36, and then 145k minus k is 144k, and then simply dividing by 36, we get k is equal to 1 over 4. So 1 over 4, those are two relatively prime integers, so all we have to do is find the sum, which is 0, 0, 5, and we are done.